So let us say this question. It reads, in triangle, this sign indicates triangle. In triangle ABC, the length AB is 7 meters, BC is 11 meters, ACB is 22 degrees. Calculate AC, and that is the length AC and angle BAC. Okay, unlike general trigonometry, we have to first draw the diagram and see how it is going to be. Good. So we draw triangle solution here. So with this triangle, let us put the vertices down. The vertices are, you have A as the top section, then we got in B, then C here, and the angle is ACB. So what it means is ACB, the angle 22 degrees is located at the point of C. So we got 22 degrees here. Good. And we have the length AB to be 7 meters. So length AB 7 meters. So what we do now is that we are using the sine rule. So it states from the diagram, from triangle ACBC, from triangle ABC, we have the length. What length are we looking for? We are supposed to look at AC. AC squared. AC squared must be equal to, that is, this part squared must be equals to, we have been given BC2. Sorry, there's BC, which is 11. So let me write it with different ink so that it becomes, yeah, this is 11 meters. In order not for it to create confusion. Good, so this is 11 meters. Good. So we have AC squared must be equals to AB squared plus BC squared minus twice the length of AB, the length of BC, cos alpha, whatever, let's use cos theta or cos 22, where theta is 22 we have here. So AC, we don't know AC, so we come here, AC squared. AB, we've been given AB to be 7 meters, so write 7 squared. We have BC, 11 squared, minus 2. Now we've got AB, which is 7 times 11, cos the angle, that is 7 has an angle of what? 22 degrees. Good. So what you just do is that this aspect is purely calculator work after you've gotten this function because of the cos 22 and the dimensions you are going to get here. So first, come down and have your AC squared. We got 7 squared is 49. 11 squared is 121 minus twice of 77 cos 22. So you take your calculator, like I have mine here. Then what you do with the calculator at this instance is you sum this value, the 49, as you have already entered, 49 plus you add 121, then you add, so 121 minus, just know that you minus twice, open a bracket, and 2, then open a bracket, you put in 7, you close the bracket on the calculator, then you enter cos, there will be bracket 22, you close the bracket. So you see you are going to get something around 27.2 on my calculator. I have AC squared to be equals to, and you are supposed to leave your answer correct to 1 decimal place, 1 dp. So you have 27.213, 27.213. Then you round to, that is running to 27.2 meters. That is the value of this part now, which is AC, 27.2 meters. Good. Then you come to the second part, which is the II. You are asked to calculate the angle BAC. This is BAC. So how do you get BAC? To be able to calculate for BAC, now I have gotten all the sides and one internal angle. So this part is facing this angle, and the 7 is also facing the angle 22 here. So in that case, we can use the sine rule. So instead, using the sine rule, what you're going to get is you are having the length AC squared, AC, the length AC on sine the angle ABC. Yes, what is the angle here? BAC. BAC. No, this is part of this and this part of that. Okay, look at it. You are being asked to calculate for what angle AC. What am I? BAC. So the angle must be here. So you can put, let's say, alpha here. So BAC is facing 11. BAC is facing 11. So you must first consider this part and the angle here. This part is facing 11. So the length CB, instead of AC, you have CB or BC for short. The length BC on the length BC, which is 11, on the angle BAC, on sine angle BAC must be equals to the length AB, because this one was given in the questioning. This part was given in the questioning. So the part which was given in the questioning must be used. Always remember, any part which the length is given, you must use it during the calculation. So this part must be used. So you have gotten the length AB on, what is the angle? ACB. ACB was given sine angle ACB. So in general, when you are putting in the entire values, the length BC, do we know BC? Yes, BC is 11. So I've gotten 11 on sine, what is the angle? The angle I don't know, so I'll put alpha here, alpha degrees, equals to AB is 7 on sine 22. Sine 22 degrees. So sine 22 degrees. What do I want? Application of cross multiplication. And when there's equal to between two fractions, so sine 22 will come here, and sine alpha will come to this part. Then 7 will divide. So just do is apply cross multiplication. So when I apply, I'm having 11 sine 22 degrees equals to 7 sine alpha degrees. I divide through by 7 because it's alpha I want. I divide here by 7 and the whole of this by 7. 7 is gone. Okay, if 7 is gone, okay, 7 is gone, I'm having, just creating a small space for myself. Sine alpha, change my ink so that it will be visible. I have my sine alpha, 11 sine 22 degrees on 7 equals to sine alpha degrees. Sine alpha degrees. Good. So if that is the case, you just point your calculator. If you look at the calculator, you see there's a point they have indicated this sign. Those that are using the 991ES. Point that one. If you point it, you will see fraction will come on the calculator. So what you do at that instant is you just go to the top, then the top here on the calculator, then you point 11, then you add the sign 22, you close the bracket for that one, then you come down, you have 7. So you are going to get 0.5886. Maintain the answer on the calculator. So I'm going to have sine alpha to be equal to 0.58866. 8866 in that order. But I want alpha, so I have to let sine cross the equal sign. So you're going to get alpha here to be equal to sine inverse the figure you have. Sine inverse 0.58866. So you take your calculator, then you point on shift sign, then you point answer. So what I'm going to do is that I go to shift sign, okay, so shift sign, then you put the figure there, 0.58866. You close it, and you are going to get your angle to be 36.06. So alpha is equal to 36.06. So running to 1 decimal point, you are going to get what? Alpha to be equals to 36.1 degrees. So this one becomes the value of the angle BAC. This question has given us the 2. This question has given us the 2. So we will take a past question on this aspect. Then we look at general trig applications. Okay, thank you.